Hey guys, it's Miss Johnson here, and I'm here to bring you our notes for Unit 2 Notes 1, which is on standard deviation. Back in Unit 1, we spent a lot of time talking about measures of central tendency. Measures of central tendency included mean, median, mode, mid-range, and the different kinds of means that we found, the geometric mean and the harmonic mean and the quadratic mean. So all of those measures of central tendency are great for finding the center of a set of data. Now we get into the standard deviation, which talks about how the data varies about the mean. So standard deviation is the measure of variance or measure of variation of data about the mean. So we're thinking about where is the mean of the data, and then what is our typical measure of distance from that mean moving out. So the closer we are to the mean, the more appropriate the data is. As we move further out, our standard deviation increases, and it could move in the positive direction or in the negative direction, because you can be below the mean as well. So you can have positive standard deviation or negative standard deviation. But it's just measuring what's the typical variation or what's the typical amount of variance from the mean of a set of data. Now, the standard deviation is kind of a lengthy process to find. I've written it out in steps, but I've also showed it to you in terms of the formula. So one thing that I want you to take note of is the fact that this little symbol right here, that is our lowercase sigma. Lowercase sigma is what we'll use for standard deviation. And then inside, here's what our formula has. We have the sum of the mean minus the data. So you're taking the distance of each data point from the mean, but you square that, add all those things together, and then you're going to divide that sum by n minus 1. And remember, n is the number of data points. All of this notation is still the same over here that we've seen. So you do all of that, and then once you're done with that, you take the square root of it. Okay, so again, we are finding the difference from the mean and the data point, squaring that, adding all of those up, dividing it by n minus 1, and then taking the square root of that. So it's a messy formula. It's a long formula. If you're a person who likes to have things in a step-by-step process, this is kind of what's happening in our step-by-step process. The first thing you have to know is what is the mean of the data. The other thing that you need to know, so that's your x bar, and the other thing you need is your n. Obviously, you're going to need to know what n is. We always need to know what n is. Then the second thing that you do is you subtract each data point from the mean. Then you square all of those differences. Then you find the sum of those differences, meaning add them up. Okay, and then you divide that by n minus 1. And then you take the square root. The square root is the very last thing that you'll do. So you've got two kind of different ways of thinking of it. You can think of it in terms of following the step-by-step process, or you can think of it in terms of plugging it into the formula. And I'm going to show you examples of both methods. All right, so here we go. Let's take a look at example 1. So finding the standard deviation of a data set. I'm going to use the step-by-step process here. So step number 1 was find my x bar. Oops, my x bar. I wanted to put a bar there, not a question mark. Okay, so what's my mean? So if you think back to finding the mean, this is just the same old, plain old arithmetic mean that we've been finding for years and years and years. The two things that you need are what's the sum of the data and what's the n. In this case, you've got 8 plus 10 plus 15 divided by 3. 8 plus 10 plus 15. If you don't have your calculator out already, I'm going to grab mine here for a second. If you don't have your calculator out yet, you might want to go ahead and grab it because you're going to use that a lot today. So my calculator, 8 plus 10 plus 15 gives me 33, and then 33 divided by 3 is 11. So my mean is 11. Okay. Then the next thing that I'm going to do, if I go back to that step-by-step process, I'm going to subtract each data point from the mean. So I'm going to take the mean minus the data. So I have 3 data points here. My n is equal to 3. I need to take the mean minus 8. I also need the mean minus 10. And I need the mean minus 15. So I've got 11 minus 8, which is 3. I've got 11 minus 10, which is negative 1. And I've got 11 minus 15, which is negative 4. Okay. So then my next step is to square that. You're going to take that whole piece and square it. Okay, so that means I've got 3 squared, negative 1 squared, and negative 4 squared. What I get there, 3 squared is 9. Now, those of you who are typing these things into your calculator, please make sure that you put parentheses around your values, especially when they're negative. If you type negative 1 squared into your calculator is going to tell you negative 1. If you do this, you're going to see that. If you do this, then what you're doing is telling your calculator that the negative and the 1 are grouped together. So the negative and the 1 need to be together in parentheses, and then you square it and you get positive 1, which we all know that a negative times a negative is positive. So this is how we need to think of it in terms of typing it into our calculator. Okay, we need to put those negatives in parentheses. When you type it in this way, what your calculator is doing is squaring the 1 and then multiplying by the negative after. That's not what you want. You don't want that. You want the negative and the 1 to be grouped together and then squared. So my negative 1 quantity squared is positive 1, and my negative 4 quantity squared, same thing, put it in parentheses, is positive 16. And again, we all know that a negative times a negative is positive, so we just need to make sure we tell our calculator that. All right, the next step would be find the sum of all of that. So then I've got 9 plus 1 plus 16. That's 17. 17 and 9 is 26. So there's my sum. The next step after that was to take that 26, you take the sum, and you divide it by the n minus 1. So I'm going to have 26 and divide it by 3 minus 1, which is really just 26 divided by 2. Or in other words, 13. And then I'm almost done. I'm on my last step. The last thing I would do here is take the square root of all of that. So I'm going to take the square root of 13. And when I do that on my calculator, I get about 3 something. Square root of 15, I get 3.61. So my decimal looks like this, 3.60555, ... Pick a place to round it. I'm just going to use the 5 and round the 0 and call it my standard deviation is 3.61. So what that means is that's the typical amount of variation amongst these 3 data points. So it's the typical amount of variation from the mean amongst those 3 data points. Okay. Now let's use that same data set and let's talk about how we could plug that into the formula. If I was going to plug that into the formula, here's what it would look like. So again, this is my formula that I'm using. You still have to find the mean first. You always need the mean and you always need the n. So that's still something that you have to do. So find your x bar. And again, that's the same as what we just did, 8 plus 10 plus 15 divided by 3, which gave me 33 over 3, which was 11. I also know that n is equal to 3, okay? So those are two pieces that I need to have. Now, if I plug my standard deviation into the equation, set yourself up a big old square root bar. I never make mine long enough. Let's see if I did it today. So what we're going to do here is we're going to, inside parentheses, I'm going to take the mean minus the data for each part. So 11 minus 8, close that off and square it. Then sum, remember that means add. So plus 11 minus 10, close it off and square it, plus 11 minus 15, close it off and square it. That whole thing gets divided by 3 minus 1. Okay, so that's what it looks like when I set it up in my formula. Now I'm going to pause for a second and I'm going to pull up my on-screen calculator so that I can show you how I type all of this in. I talked about this a little bit in the last unit, but that second answer button on your calculator is going to be your best friend. That's going to be a button that you use a whole lot, especially in big long formulas like this. Okay, so I'm going to pull up my on-screen calculator. Okay, so here's my on-screen calculator. Hopefully you can at least see most of that. I'm going to show you how I would type this in. Now this should look pretty similar to a graphing calculator. This is the TI-84. Those of you using a scientific calculator, yours is going to look a little bit different, but you can still do all of this. You still have that second answer button. You're just going to have to kind of watch where those buttons are and how it's a little bit different than the TI-84. Okay. So the first thing that I'm going to do is I'm going to take care of all that stuff in the numerator underneath my radical. So I'm going to open a parenthesis and type 11 minus 8, close my parenthesis and square that. Then I hit plus. Then I open a parenthesis again, 11 minus 10, close my parenthesis, square it, hit plus. And then I open my parenthesis, do 11 minus 15. Close my parenthesis and square it. Okay, so that's just the numerator. Mean minus data, quantity squared. Mean minus data, quantity squared, mean minus data, quantity squared. I'm adding all those together. I'm going to hit enter and get an answer there. Okay, there's that 26 that we had before. Remember that? Okay, now the next thing I need to do is I need to divide it by n minus 1. Now, obviously, I know that 3 minus 1 is 2, so I'm just going to take 26 and hit divided by 2. Because I already know what my n minus 1 is. I don't need to worry about that. And then use that second answer button. So I'm going to take second square root and second answer. Now, obviously, it's not hard for us to type in 13, but you're going to get answers sometimes that are big, long decimals, and they're not clean, nice whole numbers like this. So I want you to just get in the habit of using that second answer button because that's going to help you a lot. And there's my 3.60555 that I mentioned before. So back over here, I can now note my standard deviation of 3.60555 dot dot dot. I should have put equal signs here because I didn't round yet. Now I'm going to round it. 3.61 is approximately my answer there. All right. So formula versus step-by-step process, again, it does not matter to me. I don't care which one you use. You can follow the steps or you can plug it into the formula. You just have to be really careful about how you type it into the calculator. All right, here we go. We're going to do one more example of each method. This one I'm going to do using following the steps. So the first thing that I need to do is I need to find the mean. So step number 1, I have the mean is equal to the sum of all of that, 470 plus 170 plus 430 plus 300. Oops, almost lost a 0 there. And my n there is 4. So type all that into your calculator, 470 plus 170 plus 430 plus 300, and I get 1,370. And divide all that by 4, 1,370 divided by 4, and I get 342.5. Oops, again, I keep dropping numbers, sorry. 342.5. Okay, so there's my mean. I obviously know that my n is equal to 4. Okay, so then the next step, step number 2, I'm going to just subtract the mean minus the data and go from there. So 470. I should type it. It doesn't really make a difference, by the way, which order you subtract in. I know we always say that subtraction can't be flipped around, but in the case of standard deviation, you're going to end up squaring it anyways. So all that would do is switch your answer from a negative to a positive, and then when we square something, we multiply it by itself and it ends up positive anyways. So really it doesn't matter, but just for the sake of following the formula, I'll write it in the right way. So 342.5 minus 170, 342.5 minus 430, and 342.5 minus 300. All right, so let's subtract all those. 342.5 minus 470. I get 342.5 minus 470. Negative 127.5. 342.5. You can see that we're getting a lot of big numbers here. 172.5. 342.5 minus 430, negative 87.5. And then 342, that's obviously going to be 42.5. 42.5. Okay. Big numbers here. If you take a look at your data set, there's a 470, a 430. Those are pretty close to each other. 300 is not super far away, but 170 is pretty far away. So your data set has quite a range here. Because you have such a range, a larger range in your data set, that's why you're getting these big numbers. There's going to be a lot higher standard deviation here because your data points are so much farther apart. So that's what's happening with these large numbers that we're getting. Okay, so the next step is to square all of these. So I'm going to go through and square all of those, and I typed them into my calculator, so I'm just going to enter them in. And square that. The first one, big number, really big number, 16,256.25. And again, you should have your calculator out and be doing these with me so that you can kind of see what numbers I'm coming up with and make sure that you're typing them in the right way, on the right track. 25, the negative 87.5 squared, 7,656.25, and the last one, 42.5 squared, 1806.25. Okay, really big numbers. There's a lot of really big numbers happening here. Again, because that data set is so much further spread out, that's why we're going to, that's our, oops, step 5. Step 4. Find the sum of those. Our data set's really spread out, so that's why these numbers are turning out to be really big. So the sum of these, if I go through and add them all up. Now, if you're fortunate enough to have a graphing calculator that you can arrow up and just grab those totals that you entered, go ahead and do that. And you can arrow up and hit enter, and then do plus, arrow up and hit enter, do plus, and go on from there. I get a sum when I do, otherwise you have to type them all in, which is not that big of a deal, but if you have a calculator that allows you to arrow up and enter them in that way, that's lovely. Okay, so I get a sum of 55,475. Woo, big number, really big number there. Okay, the next step, now I'm on step 5. So the next step is to take that and divide it by the n minus 1. My n minus 1 here, my n is 4, so 4 minus 1, or in other words, it's just 55,475 divided by 3. Take that, divide by 3, and I get 18,491.6 repeating. So what's happening there? And then last but not least, I'm going to take the square root of that guy. 18,491.6 repeating. And again, second answer is your best friend here. So if I do second square root, second answer, then that pulls all of those decimals. I know we talked about this in Unit 1, how your calculator remembers a whole lot more decimals than what it can show you. It's limited on window size, so it's only showing me, my calculator is only showing me 4 6s and then a 7 because it rounds. But it knows a lot more decimal places than it's showing you. So if you do second answer, it pulls all of those places and you just get a more accurate result. So my standard deviation here is 135.98406, ... If I round that, that ends up being, that's my standard deviation symbol. That's that lowercase sigma. We'll call it 0.98. Okay, so that's our typical amount of variance from the mean. That's a lot of variance. That's a really, really high standard deviation. The fact that that standard deviation is so high, it comes from the fact that your data is much more spread out than the last data set we looked at. 8, 10, and 15 are not that far apart from each other. But these numbers here, 170 all the way up to 470, that's a lot more, there's a lot more distance, a lot more ground is covered there. Okay, we are going to do one more example together, and this one I'm going to use the formula. So again, I'll go through that on-screen calculator and show you how to plug it in there. All right, so this data set has some decimals in it, but that's okay. The first thing that I have to start off doing is finding the mean. You always need the mean. So find the sum of all of your points, plus 9.2, plus 12, plus 20, plus 16.3, and this is going to be an interesting mean because there's a whole bunch of decimals in there, and we've got an n of 1, 2, 3, 4, 5. So I'm going to divide by 5, and it's equal to 5. That's a good thing to know. I'm going to flip over to my calculator and type it in here. There I am. 8.4 plus 9.2 plus 12 plus 20 plus 16.3. I get 65.9, and then I'm going to divide that by 5. 13.18. This one. Was it 65.9? Yeah, and then 13.8. All right. So I had 65.9 divided by 5, which was 13.18. Okay, that's a messy mean. It's kind of ugly. This is where typing it into your calculator is going to be really nice, because doing that out by hand and then squaring it, you're going to have a lot of crazy decimals here if you do it that way. So give yourself a big old radical. You got 5 points to put in under here. I've got 13.18. I'm going to try and write small. Minus 8.4 quantity squared plus 9.2, or sorry, 13.18 minus 9.2. Minus 9.2. I'm going to run out of room, I can tell already. Quantity squared plus 13.18 minus 12. Quantity squared plus 13.18 minus 20. Quantity squared. Sorry, I ran out of room. 13.18 minus 16.3 quantity squared. Here's my fraction bar. Sorry, this got really messy. Divided by 5 minus 1 is what I'm looking at there. Okay, let me scroll this bad boy up a little bit and then go back to my calculator and try to type that all in for us. So open a parenthesis and you've got 13.18. Back up. Open a parenthesis. 13.18 minus 8.4. Close it. Square it, plus, open parenthesis, 13.18 minus 9.2, close it, square it, plus, open a parenthesis, 13.18 minus 12, close it, my 3 didn't show up, typed too fast, 13.18, I'm cheating and typing on my computer, minus 12, I gotta slow down because the calculator is a little bit laggy when it's on screen. And then plus, parenthesis, 13.18 minus 20, close it, square it, plus one more, open a parenthesis, 13.18 minus 16.3, close it, and square it. Phew, that's the hardest part to type in. There they all are. So that is my sum of the squared differences between the mean and the data point. Okay, the next thing I need to do is divide that by the 4. So I'm going to take that and I'm going to divide it by my n minus 1, which gives me 4. Because 5 minus 1 is 4. And there's the 24.082, and I'm going to take that and do second square root, second answer. 4.907, about 4.91. So if I come back over here, I've got a standard deviation of 4.907 ... or in other words, approximately 4.91. Again, it doesn't really matter where you round here. You can use the round off rule if you want, or you can just round to a place that seems logical, and that will work as well. So All right, so there's our standard deviation. We did 2 examples with the formula, 2 examples doing it by hand using our steps. Good luck. It's a lot of calculator keystrokes. The math is not hard, but you got to get everything in the right spot, and then just go from there. So thanks for listening and have a good day.